Okay, so to recap, y equals a times sine of b times x minus c plus d. That's the general form for a sine function. The a, the b, the c, and the d all represent values that change your graph, that put it under some kind of transformation. So a is the amplitude. That's your stretch because your graph starts with the amplitude of 1. And so your graph is going to be between these two lines. But if your amplitude is higher than 1, it's going to stretch it 2, 3, 4, and so on. The vertical shift for this is none because there's no number there. The phase shift for this is none because there's no number there. All you got to do is get in your head, these values right here is what we're looking at. And the only value that this thing has is the amplitude. So that's the only thing that's going to change. Well, probably need to say this. No, I'm not going to waste any time redoing this. Why would I do that?
Sir, you gotta stop listening. Did you see they report Nyla?
What?
To be fair, you did know that they didn't come to class after they were done. So then we had to go take them home. Who was out there? But to be fair, you know, when we came out there, can you please go back up? I don't know where y'all, and y'all was going so fast because I just seen y'all. And where we were there. You the ops. Hey, yo, don't sit in the car with me because I will spit on y'all. I said, stop. I'm gonna tell him. She got a bottle of them. She got a bottle of them. I'm gonna keep her off. I won't give time for nobody. Not even my mom.
So let's talk about this special triangle, the 30, 60, 90 triangle. So 30, 60, 90 triangle has the following general measurements, all based off of the side that's opposite 30, which is x. So we've got x times the square root of 3, and 2 times x. Well, the special triangle that I'm focusing on is the one for the unit circle. And the unit circle has a radius of 1, which makes our hypotenuse 1. So if I want to find the values for this, all I need to do is look at the general definition for the 30, 60, 90, and then I look at the specific definition for this unit circle, and that tells me I've got 2x equals 1. So I solve that, and that gives me x. Divide by 2 on both sides, x equals 1 half. So x equals 1 half. So this value right here is 1 half. And if that value right there is 1 half, this value is 1 half times the square root of 3. But you'll more often see it written as the square root of 3 over 2. And what are you confused about? Okay, so let's see if it clicks now. This is the general definition. That's the general definition of a 30, 60, 90 triangle. the hypotenuse is going to be 2 times x. Here is a specific definition of the unit circle version of the 30, 60, 90 triangle, where we know that the hypotenuse is 1. If that is the general and this is specific, so then I say, hey, 2x should equal 1. So then I solve that equation. 2x equals 1. I need to isolate x. How do I isolate x when it's 2 times x? I do the opposite of times, which is division. The 2's cancel off, and I get x equals 1 half. So now I know that x is 1 half. Because I know that x is 1 half, this is 1 half times the square root of 3. But if I think about 1 half times the square root of 3 is 1 half times the square root of 3 over 1, I get the square root of 3 over 2, which is how you'll more often see it. Any questions? Yes. So then I got the same thing here with this 45, 45, 90 triangle. So the general form of this is that the two smaller sides, or the legs, are x, and then 30, 60, 90, 45, 45, 90. What's this triangle called? I said it's the unit, it's the triangle, it's the 45, 45, 90 triangle from the unit circle. Yes, because the unit circle has a radius of 1 that also makes my hypotenuse 1. So I do the same thing I did in the other problem. X times the square root of 2 equals 1. I divide by square root of 2. So I get x equals 1 over the square root of 2, but I can't leave it like that. I got to rationalize. So I multiply by the square root of 2 on top and bottom, and I get x equals the square root of 2 over 2. So that's this value and this value. And that's it. And you're going to be using these for several different problems. So it's good to know. It's being recorded. That's kind of the whole point. So you could go back and look at it. So I'd spend class time going through as much as I could, as opposed to waiting till you write something down. So what the heck is this talking about? Evaluating. So there's probably a bunch of ways you could evaluate this, but here's the way that I'm gonna suggest you do it. I'm gonna say that what you need to do is you take your radian measure and you change it to degrees. So 2 pi over 3. Now how do I change that to degrees? 180 over pi. Pi's cancel off. I could multiply straight across and get 360 divided by 3, or I could cross cancel and I get 120. Either way, you get 120. Oops. So now I know that this is sine of 120. So the first question that I want to answer is, what quadrant is 120 in? It's in the second quadrant. Oops, quadrant, not quadrant. Quadrant. So that's in the second quadrant. If you say quadrant 2, I wouldn't trip about it. Um, the next thing is, okay, so now that I know where the quadrant is, I want to take the sine of this. Well, there's a couple things you could do. You could just look at this. What's the answer? could just look at this. What's the sine of 120? Yeah, I'm trying to make sure you understand how to read this. No. Mm-hmm. Square root of 3 over 2.
It's cosine different. Oh, okay.
Could you curse a little louder, please? Right here. Right here. It says it right here. So you do the same thing for evaluating the cosine of 5 pi over 4. Now, technically, if you're going to use this, you wouldn't even have to change it to degrees to see what quadrant it's in. But I still think you should. So what quadrant is 5 pi over 4 in? It's in the third quadrant. Okay? And what was it, 225? So what's the cosine of 225? There you go. Yippity doo dah. Reference angles. Yes. Okay, I don't know what that means, but okay.
The cosine from the chart, do we just put the angle? Because yesterday you said we could just put the angle. Like if I left it as 120, that is fine and still be right.
No, because that wasn't it. That wasn't what I said. I said I would change it to degrees and then find it. This is the answer. You need to know how to find a reference angle. And depending on what quadrant you're in, if you're in the first quadrant, your reference angle is just the angle. If you're in the second quadrant, your reference angle is 180 minus your angle. If you're in the third quadrant, you take your angle and subtract 180 from it, and that's your reference angle. And in the fourth quadrant, you take 360 and subtract your angle from it to get your reference angle. That's that. Now, I am not giving you this, so you need to write that down wherever you're going to write it. I'm not giving you that, so you need to write that down wherever you're going to write it. But when we did these two problems, it's a start. So what I need you to do is I need you to think of two values that are radians that add or subtract to the value that I give you. So, so that's pi or 1 pi over 12. And you think of two values that add or subtract to give you 1 pi over 12. Mm-hmm. 4 pi over 12 minus 3 pi over 12. Now, the reason I chose those was because when I reduce 4 pi over 12, if I divide by 4 on top and bottom, I get pi over 3. Pi over 3 is 60 degrees. If I take 3 pi over 12 and I reduce that, dividing on top and bottom by 3, I get pi over 4. That's 45 degrees. So I'm trying to keep the values that I use either some variation of 3, pi over 3, pi over 4, or pi over 6. So that's 30 degrees. Because those are values that I know. Say it again, ma'am. Okay. I've used it before. But so anyway, now that being said, I could also use some variation at the reference angle is that. But don't think too hard. Like for instance, 7 pi over 12. That's 4 pi over 12 plus 3 pi over 12. 4 pi over 12 plus 3 pi over 12. Again, those reduce to 60 and 45. And then, couldn't hear you, ma'am. Yep, I think I did that once. Let's see. Pi over 4 minus pi over 6. Let's see, that's 12 as a common denominator. That is what? 3 pi over 12 minus 2 pi over 12. So you can use those two to do that one. So that's another way you could do that. So now what are we doing with that? Why did we do that? Well, because we've got these addition and subtraction identities that say if I got sine of two things that are added, in order for me to find the actual value, I use this formula right here. So what I'm looking for right here is sine of pi over, what's that, 3 minus pi over 4. So I just plug and chug in there. So I got sine pi over 3 times cosine of pi over 4 plus cosine of pi over 3 times sine of pi over 4. Subtract that how? Oh, shoot, I grabbed the wrong one. You're right. I'm sorry. Yep, I should have did this one, not that one. So anyway, um, what is sine of 60 degrees? What's sine of 60 degrees? Can't hear you. 1/2. And then what's cosine of 45 degrees? 2 over 2 minus. And then what's cosine of 60 degrees? You need to be able to read this thing if you're going to use it. Square root of 3 over 2. And then what's sine of 45? Square root of 2 over 2. And then I just multiply those things out. So that's 1 times square root of 2. That's square root of 2. 2 times 2 is 4. Minus square root of 3 times the square root of 2. That's square root of 6. 2 times 2 is 4. And because the square roots aren't the same, you can't add them. So the only thing you could do is just put them over the same value. So either one of those is my answer. That's how you do that. So you need to write these somewhere because I'm not giving them to you. There's a couple matching. So there's some graphs and some equations that you need to match. So the big thing is remembering what this means. Amplitude. So if I'm looking at a graph, it's like, come on, further, let's see. Okay, right here. Yeah, that moves down. Okay. So the amplitude for this is 3. Because here's my midline right here. That's the middle line. And the distance from the middle line to the highest point or the middle line to the lowest point, that's my amplitude. Uno, dos, tres. So for D, I know that my amplitude is 3. Second, it starts at 0 and it goes to 2 pi. So that's a sine graph. So I know that's a sine graph. And because it goes from 0 to 2 pi, I know that my frequency is 1. The frequency is 1. Because from 0 to 2 pi, there's only one cycle. So then that means I just got X. Okay. Now it's making me a liar because I don't see it. That's interesting. Is that's what that looks like. I don't see it. I'm still trying to say this is it. Hmm, interesting. So I'll say again, it all goes back to knowing about this. Amplitude. If it's negative, then you got a reflection. B, that's the frequency. You divide that into 2 pi to get your period. This value, that's my phase shift. That's moving it left or right. And remember, your phase shift is the opposite of where it's going to go. So if I got x plus 1, it goes to the left. If I have x minus 3, it goes to the right. That's for the phase shift. But then the stuff on the outside, the D, the vertical shift, positive goes up, negative goes down. Does anybody got any questions on that? That's going to bug the heck out of me now. Hmm. Oh well. I'll say again, does anybody have any questions? Okay, well, let's take a few minutes to look at their red now. Let's look at them more interesting one. Okay, so the law of cosines. The law of cosines is based off the Pythagorean theorem. And so if I have some kind of triangle that's in this format to where I've got, A, B, and C, and then I've got that angle is referenced to its opposite side. So I can use one of these when I know two sides and the angle between them, or if I know all three sides. That's kind of in contrast to when I can use the I can't even say it, the law of cosines. Law of cosines is when you have one definite side and one definite angle, and then you have a side or an angle because I'm using some kind of ratio. So if I have two sides and one angle, I can figure out the leftover angle. And conversely, if I have two angles and one side, I can figure out the side just by doing some cross multiplication. That's how the law of sines work. Law of cosines, like I said, is a little more intricate. It's just a plug and chug thing. I got got several different values I need to find the missing value that I want. So it's just a matter of plugging and chugging. You know, if I want this side C, I need to know this angle, this side, and this side. And then I just plug them in there. And let's see, did they give us, nope, they gave us all the sides. So let me see if they give us one with an angle. Okay, yep, there's one with an angle. So right here, I want to find side C. So I got A squared plus B squared minus 2 times A times B times the cosine of 134. Now, you have to use a calculator for that, and that gives you some decimal. But then, I guess you can use a calculator for the rest of it. What's that? 400 plus 64 minus 2 times, what is that? 1600 times whatever that is. That's a cosine 134. So cosine of 134 is negative 0.694 7. Yeah, I rounded off to 4 decimal places. So then I multiply all those values. Negative 2 times 1600 times this negative decimal, and then add those two and subtract whatever that is. What's that? Negative 0.06947 times. Well, that's going to be plus 2.2304. So 464 plus 22.2304. Yep, that's a negative 2. But this is also negative, so the negatives cancel each other out. So my final answer, 0.2304. That's my final answer. And then you want to pay attention to the problem, because the problem will usually tell you what you rounded off to. Whether it's the nearest whole number, whether it's the nearest tenth or the hundredth or whatever. Well, that's how you do the law. Yes. I multiplied I multiplied these three things together. Yes. And then if we go up to say, wait, what? Like I said, you can look at the video to write it down. So, let's see about this one. It's just a matter of plugging in and chugging stuff, and then you can just put it in a calculator. So, B, C, and little c. So B is 10, C is 100. That's 115. So see, I know that sine, nope, not sine, sorry. Let's say C over sine of C equals B over sine of B. I know the angles. I know this side. The one side I don't know is that one. So that's why I want it on top. So that's 115 over sine of 100. And that should equal B over sine of 10. And so then I just cross multiply this. Multiply those two things and divide by that. What's that? 115 times sine of 10. Add. Start over how? Okay, so I just did on the calculator. 115 times the sine of 10. I got 19.9695, and then I need to divide that by sine of what's that? 100, and I get 20.2776. So again, depending on what your instructions tell you to round to, it could be 20, or it could be 20.3, or it could be 20.28.